A question that I get quite frequently is, why is water polar? Why is water H2O a polar molecule? So in this video, we'll look at two main reasons. First, the shape of the water molecule. And then we'll look at the difference in electronegativity between the atoms. So both of these ideas here are important when we try to look at the polarity of the water molecule. Right here we have a Lewis structure for the water molecule. You'll notice we have two lone pairs up here. These are unbonded pairs of electrons. And this single bond here, this covalent bond right here, that's made up of a pair of electrons. It's shared between the oxygen and the hydrogen. Same over here. So oxygen has 8 valence electrons around it. That's good. Hydrogen has 2. That's good as well. So this is our Lewis structure. Let's talk about how we can look at the Lewis structure to understand the shape of the water molecule. So the purple, that'll be that central oxygen atom. And then we're going to add 2 hydrogen atoms. One here and the other right here. And they spread out. They push away to be as far as they can from each other. But we've got to remember those lone pairs. They occupy space as well. We had 2 lone pairs. We add 1. You can see how it forces those hydrogen atoms down. Now they're down there lower. And then we add another. Maybe forces it a little bit lower. And we end up with what's called a bent molecular geometry. So the shape of water is bent. And we can see kind of we have a top here with the oxygen and the hydrogens are down here. So it's not symmetrical across this plane here. Let's go back to our Lewis structure. So here we have the bent structure for the water molecule. We've not drawn those lone pairs up here, but we can imagine they're pushing the hydrogens down. But what we're really interested right now in is this bond right here, these electrons shared between the oxygen and the hydrogen. If we looked up the electronegativity value for oxygen, we'd find that it's 3.5. Hydrogen is 2.1. So we have a big difference in electronegativity. It's about 1.4. If our electronegativity difference is between 0.5 and around 2, we'll have a polar molecule. So this is definitely a polar molecule because of the shape and because of the electronegativity difference. So because the oxygen is more electronegative, these electrons that are shared, they're going to spend more time with the oxygen. So these electrons will spend more time with the oxygen, and that'll make it a little more negative. So if we put the Greek symbol delta in here, and we write negative for the oxygen, the hydrogens, those are going to be positive. And now you can see we have our poles, so we have a polar molecule. Let's look at the surface. Let's color code the surface of our molecule to really see that polarity. So here's our water molecule. And remember that the red, that's the oxygen, that's more negative, and the hydrogens, they're more positive. So we'll color code this, and the red is the more negative area, the blue more positive. And you can see clearly here that water is a polar molecule. We have the oxygen around that, that's going to be red because it's more negative, and then around those hydrogens, blue because it's more positive. So again, water is a polar molecule. What happens if you put 2 polar molecules next to each other? So press pause and think of how these 2 water molecules might rotate and line up. Remember, opposite charges attract. So let's turn the blue this way, and then with this water molecule, we would expect that the red, the opposite pole, would line up and they would be attracted. In fact, with water, because there's such a big difference in electronegativity between the oxygens and the hydrogens, we have a weak bond formed called a hydrogen bond between the water molecules. It's weak, but it does explain a lot of the properties of water, like a higher boiling point. So to recap, the shape of the water molecule, that means on top we have the oxygen, which is more electronegative because it has these electron pairs pulled towards it more tightly. And on the bottom we have the hydrogens, which are more positive. That gives us poles, means water is a polar molecule. This is Dr. B answering the question, why is water polar? It's because of its shape and the difference in electronegativity between atoms. Thanks for watching.